Okay, so this is how your rules are traced back, and this is essentially what your uh, instantiation works, how instantiation works with respect to variables and your associated facts. Okay, now understand what recursion, if we go back to recursion. Now recursion is actually, we've studied this before, and it basically means that you have specified a subroutine, and the definition of the subroutine is calling that subroutine itself. So it's defined in by calling itself. And we also remembered that all recursive subroutines have a general case and a base case. And at each recursive call, the general case will have to reach the base case, and has to be a finite number of calls. Eventually, it reaches the base case. So if we go back to our factorial example, we have the function definition factorial, and I'm also calling factorial over here as well. So basically, if I want to find the factorial of 5 or 3, for example, I will pass 3 here. But for 3, I will first have to find the factorial of 2. And then I will have another recursive call with 2 as a parameter. For finding 2 factorial, and at each time I'm comparing my base case. So I started off at 3. If n is equal to 3, is n equal to 0? No, it's not. So this base case has not been achieved. I move towards the general case. And if I start off with 2 as factorial, 2 factorial, 2 is my parameter. Is it n is equal to 0? No, it's not. I moved to another general case. Now I start with factorial 1. N is now 1. This is another recursive call. Is n equal to 1? Base case achieved? No. I move towards the general case. This time I'm running factorial 0. Now n becomes 0. Yes, now my base case has been achieved. In which case, the base case, the only result I know. So n factorial of 0 is 1. So since I go back on the upper layer, now since I have the factorial of 0, which is 1, I can find the factorial of 1. Since I have the factorial 1, I can find the factorial of 2. If I have factorial of 2, I can find the factorial of 3. So basically, starting down on the top layer, going down to the base case. Base case is where I first have the occurrence of an actual result. And then I use that result of the base case and use it on the upper layers until I reach the topmost layer. So we have discussed the recursive functions in great detail. You can visit that video again and revise that concept. Now, how is factorial function, how is recursive function being applied to your prologue? Now, this is interesting. This is a fact. The factorial of 0 is 1. So basically, this is my general case. The factorial of 0 is 1. Okay. Sorry, this is my base case. 0, factorial of 0 is 1. And this is my sort of general case. And I'm defining a rule here that the factorial of n will be result. Now, notice that these are both variables. The factorial of n is a result. If m is n minus 1, as you can see here, when we go back one layer, we actually, for finding the factorial of 5, I have to first find the factorial of 4. So basically, first I do is I have to decrement my factorial, my original value. So if I started over 5, now I start off with 4. Now basically, how to read this is m is n minus 1. So if my n was 5, now my m becomes 4. And start off by finding off the factorial of 4. And this is where my recursive call starts. So my factorial of 4 will become my partial result. And when I come back, and my result is actually, the real result is actually partial result multiplied by the value of n. So as you remember here, the factorial of 4 is actually 4 multiplied by 3 factorial. So if my factorial of m is partial result, the actual result is partial result multiplied by n. So if factorial of 3 is my partial result, my actual result is 4 multiplied by factorial of 3, partial result. So that's what's happening over here. So if m The factorial of m is corresponds to my partial result. When I have the factorial of m, that will be my partial result. And when I multiply that with n, I will get my actual result. So this is my definition over here. Now, pay very close attention. Let's assume that I'm starting off with 3 factorial. Now, the factorial of 3 will be result. Now I'm trying to find out what that is. So to find out the factorial of 3, I will first assign m as 3 minus 1. So that's 2. I will start off finding factorial of 2. And the factorial of 2 will correspond to my partial result. That this results in my recursive call. This is my recursive call. So I come back up. This time I'm running 2 as my factorial, and that will make up my result that time. So 2 with 2 as my basic value, m will become 2 minus 1, which is 1. And I'll start off with 1 as my partial, 1 factorial will correspond to my partial result. And at each layer, I'm checking whether or not I have reached m as 0. If I have reached m as 0, that means my prologue states that the factorial of 0 is 1. So that's the only value I do know. So if, say, for example, I reached m as 0, that means my partial result will be 1. So that means that if I have partial result 1, I multiply with the original n, I get the whole result. And I carry this result upwards to get the final answer. So it's not as straightforward as we can see in our, what you call it, high level programming language. But yes, Prolog is a language that also is capable of applying recursion. And as you can see, I tested the code here with n being 5, and I am asking what the answer is. And when the whole Prolog runs in a recursive way, it finds out that the answer should be 120. And if we calculate this, find the factorial of 5, it will in fact be 120. So this is how factorial is applied in terms of your Prolog. Okay, now I'm going to be using this example. This example will basically give us an idea of how instantiation and backtracking works when I have a knowledge base written in this way. So this example was found on the internet, and it actually was a very interesting example. We've got these multiple facts over here, and I've got a rule over here. So we can say that female Marge is a female, Lisa is a female, Maggie is a female, Maggie is a female, Wilma, Pebbles, Homer, male, Bart, male, Fred is a male, parent Marge is a parent of Bart, Homer is a parent of Bart, Marge is a parent of Lisa, and so on and so forth. Now, there's a rule that says that X is a father of Y if X is a parent of Y and X is a male. So this is my basic, facts. All of these are facts, and this is my rule over here. Now, let's say that I want, this is my query right here, right? Now I want to find out who are males. So basically what happens is that my Prolog will start searching from top to bottom, and we would look through all of the facts, all of the facts written here with male as the predicate. So as you can see here, I find one, I start from the top, as Prolog starts from the top, and the first instant that I see, our Prolog sees male as the predicate, since it's got male here, as it got male over here, that means since this is male, X must be Homer. And so that's why the first instant where X has a value is with X is equal to Homer. But as always, it doesn't stop here, it moves ahead and finds another fact where male is the predicate. And this time it associates the value X with Bart and moves on and finds another predicate where X is associated with Fred. Now, as you can see here, there are no more facts where male as a predicate, and that's where we can end it. So that's why you can see the first instant it finds male true to be it's X is equal to Homer, then X is equal to Bart, then X is equal to Fred. Homer, Bart, and Fred. So it starts from the top and simply matches the male part of this predicate and simply associates X with the parameters that it sees on the way. Starts off with Homer, that's the first thing it sees, Bart and Fred. Okay, now let's see this fact right here. I'm searching for this query. I'm basically asking who is the father of Bart. So now basically what's gonna happen here is that my prologue will start searching from the top and find a rule somewhere that starts with father. Yes, we found it. Okay. The rule states that X is the father of Y. So I've got, it's a coincidence that the knowledge base also mentioned X, that it's not necessary, but it could be any other variable as well. But that's just, it's a coincidence that X matches here, not always the case. So anyway, I have found a rule by the name of father in my knowledge base, and that rule says that X is the father of Y. So I have another variable here. So I don't know what this X is, but I do know what Y is. So I'm going to instantiate Y instantly with Bart. So now I have instantly instantiated Y with Bart right here. As you can see here, Y is Bart. Ignore this part. I just discussed this sequence that I started searching from the top and reached the rule where it says father. So the first instant where I found father, the Y value is instantiated with Bart. Now I have another goal that tests the second part of this rule, that X should be parent of Y. I just established that Y is Bart. So now I start searching for who is the parent of Bart. Y is Bart. Who is the parent of Bart? So again, starting from the top, I've got the first instant where I have parents is where Marge is the parent of Bart. So now, as you can see here, this rule satisfies the Bart parts. Okay, Y is Bart. Yes, I got Bart over here. So that means X must be Marge. Okay, agreed. It can be. So that's why I have X as Marge. As you can see here, X as Marge, because it's true. My parent, second part of the rule, Bart part is true. And that means X must be Marge. So I have satisfied one aspect of this further rule in which I have established that X is a parent of Y, and I found Y Bart to be true for X as Marge. So that's why X is instantiated with the value Marge. Now I'm moving on to the second part of this rule, in which I'm trying to find out the fact that states that Marge is a male. Now my second rule starts with trying to find Marge as a male. So that means this is my new rule. I'm trying to find a fact that says that Marge is a male. Obviously, I will not find it, but I will still look for it. I start from the top, male, male, male. Yes, I found the first predicate. Marge as male, no. Bart is no Marge here, no Marge here. Okay, that means after reading the entire knowledge base, it is established that there is no fact in which Marge is a male. So that means the second part of the rule in which Marge is a male is not true. So that means Marge is not a father of Bart. So that means I have not satisfied this part of the rule. That means the next thing I will do is I will go backtracking. Now this step is known as back. Now what is backtracking? Backtracking means that I move back to the previously successful fact. Now previously successful fact was that Marge is a parent of Bart. That was my previously successful part. That's why I determined that Marge, X must be Marge, and that's why I started searching for a fact that states that Marge is a male. But my successful fact was Marge is a parent of Bart. This is true. So since Marge was not a male, and the male Marge is a male fact that was not found, that means I will backtrack to the last successful goal, my last successful fact, which is Marge is a parent of Bart, and I start searching again from here. So this backtracking process will lead me back to this last successful fact. And now I will start moving on from here. I have another fact here which satisfies the Bart's x y is equal to Bart's section. Since y is again Bart matches here, there's another fact in which Bart matches here. And this time, since I have x, Homer should be x right now. So that's why I have another fact where Homer is a parent of Bart, and another instant where this rule becomes satisfied. Yes, Homer is a parent of Bart. So that means X is Homer. So the second part of this rule is I want to establish, is there any fact that has male as Homer? Yes, there is. Let's try searching from the top. No male, no. Okay, we got a fact that says male here. Okay. Now, is Homer a male, a fact mentioned here? Yes, there is. So this time around, my second part of this rule is also true for X is equal to Homer. That means since X is a parent of Y, fact is true for Homer is a parent of Bart. And the second part is also true in which Homer is also a male. That means X is a father of Y, with X being Homer, father being Y of Bart is also true because I have satisfied these both facts. That means the rule that Homer is the father of Y must be true. And that's why my rule here is satisfied. Okay. So this is the concept of instantiation in the backtracking, that in which I try to establish, I find the first fact that satisfies this rule and this fact, and then I try to satisfy this other fact as well. But if other fact is not satisfied, I backtrack to the last successful fact and start searching again from there to try in attempt to find the second part that is true. So this is instantiation and backtracking.